Hello everyone, welcome to Pre-Algebra Lesson 5. So in this lesson, we're going to start a new topic on exponents. Okay, so we're going to divide our lesson today in 3 parts. In the first part, let's look at the basic concepts of exponents. Then we will discuss the operation properties on exponents. And lastly, we have a set of exercises that reviews these concepts and properties together and put them in practice. So let's start. Let's look at the basic concept of exponents. So what is an exponent? Exponents are used to represent repeated multiplications. So if I let a represent any number, a times itself can be represented as a with a superscript 2 next to it. Now if I have 3 a's multiplied together, then it can be represented as a with a superscript 3 next to it. Okay? And similarly, if I have 4 a's multiplied together, then I have a superscript 4 next to the a. Okay? So if we generalize it and I have n a's multiplied together, then it's simply a with a superscript n next to it. Okay? So a here is the base and n is the exponent. Okay? So a with a superscript n can be read a couple of ways, and sometimes it's read as a raised to the nth power. You will also hear a to the nth, okay? Or you will also hear a to the power of n. Okay? All of these are ways that to represent a with a superscript n. Okay? Now, specifically for convenience, a to the power of 2 a lot of times is simply being called a squared. Okay? Or a to the power of 3 a lot of times is simply being called a cubed. Now let's look at some examples. On the first line, we have 2 to the power of 1. So that means we'll only have 1 2. And the answer is 2. On the second line, we have 2 to the power of 2. This means that we have 2 2's multiplied together. So that's 2 times 2. And that gives 4. On the third line, we have 2 to the third. Okay, this represents we have 3 2's multiplied together. So that's 2 times 2 times 2, and the answer is 8. Now on the next line, we have 2 to the power of 4. That means we have 4 2's multiplied together. Okay, and that gives the answer of 16. On the next line, we have 2 to the fifth. That's we have 5 2's multiplied together, and that gives 32. Okay, so then we have 2 to the power of 6 is 64. 2 to the power of 7 is 128. 2 to the power of 8 is 256. 2 to the power of 9 is 512. And lastly, 2 to the power of 10 is 1024. Okay, all right, so these lines sounds pretty dry. And here comes the fun part. And the fun part is to memorize all of them. Okay, you're probably thinking this sounds crazy. How is this fun? Now, these occur a lot in computations. It can be in the homework, in your test, or a math competition. And when they occur, you won't be troubled by calculating them. The answer will come right off the bat, so you can enjoy the actual fun part of solving the problem. Okay, so memorize all of them, just like you memorize your multiplication table. Now, all of these are 2 based. Okay, so that is there are 2 to the first, 2 to the second, 2 to the third, etc. Now let's look at some 3 based. 3 to the power of 1 is 3. 3 to the power of 2, which is 3 times 3, is 9. Okay, 3 to the power of third is 27. 3 to the power of fourth is 81. Okay, and some 4 based. 4 squared is 16. 4 cubed is 64. 4 to the fourth is 256. And let's look at 5 based. 5 to the first is 5. 5 second is 25. 5 to the third is 125. 5 to the fourth is 625. Okay, so again, you're encouraged to memorize all of them. So by now you have established the concept of exponents. And let's start to look at some properties of exponents. The first one is multiplication of exponents having the same base. So what we have here is a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. Now let's keep that in mind and let's look at some examples. Let's look at the example on the left first. We have 2 to the third multiplied by 2 to the 7. So these two terms, they both have the same base, and which is 2. So we can use this property right here and rewrite this expression as 2 to the 3 plus 7's power. And this gives us 2 to the 10's power, which is 1024. Okay. Now let's use another way to compute this problem and see if we get the same answer. 2 to the third means we have 3 2's multiplied together. And then multiply by 2 to the 7's. 2 to the 7's means we have 7 2's multiplied together. Okay, so there are 7 2's here. Okay, now let's take off the parentheses. What we essentially have is 3 2's followed by 7 2's. Okay, so if you count all of them together, there are 10 2's here. So that's essentially 2 to the 10th, which is 1024. Okay, so we have the same answer. Now let's take a look at this problem on the right. We have x to the third multiplied by x squared. Okay. Again, similarly, these two terms, they have the same base, which is x. So according to the property, we can do x to the power of 3 plus 2. And this gives us x to the fifth. Okay, so that's the answer. Now again, let's use a different method and compute it, see if we get the same answer. So x to the third is 3x multiplied together. Then we have multiplied by x squared, which is 2x multiplied together. Taking out the parentheses, we have 3x followed by 2x. And altogether, these are 5x's multiplied together. So that's x to the fifth. Okay, so we have the same answer. Now let's look at our second property, the exponent of exponent. Okay, it says the exponent a to the m raised to the nth power is equal to a to the power of m times n. Again, let's keep things in mind and let's look at some examples. Let's look at the numbered example on the left first. What we have is 2 to the third, this whole thing, raised to the second power. So if we use the exponent of exponent properties rule right here, this can be equivalently rewrite as 2 to the power of 3 times 2. And this is 2 to the power of 6, which is 64. Now let's use another method to solve this problem and see if we come up with the same answer. Let's evaluate inside the parentheses 2 to the third first. So 2 to the third is 3 2's multiplied together. Okay, so that's inside the parentheses. And then same, we're going to raise to the second power. Okay, 3 2's multiplied together is 8, raised to the second power, a squared is 64. So we have the same answer. Okay. So similarly, for this one on the right, the base is x. Okay, so x to the third, this whole thing raised to the sixth power. Okay, using the property rule, this can be rewritten as x to the power of 3 times 6. And that essentially is x to the power of 18th. Let's look at our third property, exponent of product. Let's say that we have two numbers, a and b, and their product, a times b raised to the nth power, is equal to a raised to the nth power multiplied by b raised to the nth power. Okay, so keep this in mind, and let's look at an example problem. In this example, we have 3 times 2, the product raised to the third power. Okay, if we use this property right here, this is the equivalent of 3 to the third power multiplied by 2 to the third power. Okay, so 3 to the third is essentially 27, multiplied by 2 to the third is 8, and this gives a final answer of 216. Now let's use a different method and see if we can come up with the same answer or not. So let's evaluate inside the parentheses first. 3 times 2 is 6, so this essentially is 6 raised to the third power. Okay, so that's 36 multiplied together. Okay, so that's 36 multiplied by 6, and the answer is also 216. So we have the same answer. Moving on to our fourth property, the division of exponents. So if we have two exponents, okay, where they both have the same base, so that's we have a to the m divided by a to the n. Okay, and that is essentially equal to a raised to the power of m minus n. Okay, keep this in mind, and let's again look at some example problem. In this example, we have 2 to the power of 5 divided by 2 to the power of 3. So both terms have the same base 2. So we can use this property and rewrite this expression as 2 raised to the power of 5 minus 3. Okay? So that is 2 raised to the power of 2. And that gives us an answer of 4. Now let's use another method and recompute this problem. So 2 to the 5 is 2 times itself 5 times. So we have 5 2's here. Okay. And then divided by 2 to the third is 3 2's multiplied together. Okay. So here we have 5 2's divided by 3 2's. So we're left over with 2 2's. Okay. And the answer is also 4. In this next property, we're going to look at exponents applied to a reciprocal and negative exponents. So in this expression, we have a to the power of n divided by a to the power of n. So we have a number divided by the number itself. So we know that always equal to 1. So keep that in mind. Here we have two exponents of the same base divided from each other. And from previously, we know that's equivalent to a to the power of n minus n, which is a to the power of 0. So here we can derive that a to the power of 0 is equal to 1, since we know that this expression evaluates to 1. So any number raised to the power of 0 is always equal to 1. Now if we have an exponent n that's applied on a reciprocal 1 over a, this is defined as 1 over a raised to the power of n. So here 1 can be rewritten as a to the 0 from here. So this is essentially a raised to the power of 0 divided by a raised to the power of n, which is a raised to the power of 0 minus n. And that's a raised to the power of negative n, a negative exponent. Okay. So here is the negative exponent. If we have a number that's raised to the negative exponent, this is the equivalent of 1 over this number raised to the positive exponent. So a raised to the power of negative n is equal to 1 over a raised to the power of n. Okay, let's take a look at an example. Here we have an exponent applied to a reciprocal 1 over 2. So by definition, this is the equivalent of 1 over 2 raised to the power of 3. And this equals to 1 over 2 raised to the power of 3 is 8. So this exponent right here evaluates to 1 over 8. Now let's take a look at this one. In here we have 2 raised to a negative exponent, negative 3. So by definition, this is equivalent of 1 over 2 raised to the positive exponent, which is 3. Okay? 1 over 2 to the third is 8. Okay? So this also is equal to 1 over 8. So you can see that these two exponents are the same. In this last property, let's look at exponents applied on negative numbers. So if you have a negative number raised to the odd power, the end result will always result in a negative number. But if you have a negative number raised to the even power, the end result will always be a positive number. So let's look at this example here where the number negative 4 is raised to the even power. Okay, this is essentially negative 4 multiplied by negative 4, which is 16. So another way to look at this problem is you have 2 negative 1 multiplied by 2 fourths. Okay, so negative 1, if you have even number of them multiplied together, it will always result in 1. So that's where the negative disappears. Okay. Now in this problem, we have negative 4 raised to the third power. That's essentially 3 negative 4 multiplied together. And that's 16 times negative 4, where the end result is negative 64. So similarly, another way to look at this is, in this problem, you have 3 negative 1s multiplied by 3 fourths. So if you have all number of negative 1s multiplied together, the end result is always a negative 1. So that's where this negative came about. So this covers all the exponents property we want to discuss in this lesson. Next is a set of exercises that uses different combinations of these properties. So you're encouraged to pause the videos and attempt them yourself first. And if you're stuck, refer back to the lesson notes and try to reattempt them again. Let's look at our first exercise problem. Evaluate the expression negative 1 raised to the power of 5 squared plus 1 raised to the power of 2 to the fifth. So the challenge in this problem is that the exponents themselves are exponents. So let's first simplify the exponents. So in this one here, we have 5 squared. That is 2 5s multiplied together, which is 25. So let's simplify this one. We have negative 1 raised to the power of 25ths plus 1 raised to the power of something. Now 1 raised to the power of anything is always equal to 1. So that's 1 here. If you're not fully convinced, 2 to the fifth is equal to 32. Okay, so 1 raised to the 32nd power is simply 32 ones multiplied together, which is 1. Okay, so let's continue. Here we have negative 1 raised to odd power. Okay, negative 1 raised to odd power is always equals to negative 1. Then we have plus 1. So the end result is 0. Let's look at our next exercise problem. Given that 1 squared plus 2 squared plus 3 squared, so on and so forth, to 25 squared is equal to this number right here. Evaluate the expression 2 squared plus 4 squared, so on and so forth, to 50 squared. Now notice that this expression here are 25 exponents with bases of consecutive even numbers. So we want to try to find the relationship of this expression with this expression on the top, what's given, so we can utilize this number. So let's explore in that direction and see what we can get. Now if you notice here, look at the base. We have 2, 4, 6, 8. That's essentially 1 times 2, 2 times 2, 3 times 2, 4 times 2, so on and so forth. Okay, so we have 1, 2, 3, 4. Some kind of correlation already start to appear. Okay, so let's see if we do it that way, what we get. So 2 to the power of 2 is essentially 1 times 2 to the power of 2 plus 2 times 2 to the power of 2 plus 3 times 2 to the power of 2 plus 4 times 2 to the power of 2 plus so on and so forth plus 25 times 2 to the power of 2. Okay, so if we use the property on exponents of products, what we essentially have is 1 squared times 2 squared plus 2 squared times 2 squared plus 3 squared times 2 squared plus 4 squared times 2 squared, and then so on and so forth plus 25 squared times 2 squared. Okay? Now if you notice here, each term here has 2 to the power of 2. So that means we can actually factor out the 2 to the power of 2 and group the rest of the term without this 2 to the power of 2. So that leaves us with 1 to the power of 2 plus 2 to the power of 2 plus 3 to the power of 2 plus 4 to the power of 2 plus so on and so forth plus 25 to the power of 2. Okay? So now you probably already start noticing something. 2 to the power of 2 is 4. Multiplied by this entire expression inside the parentheses is essentially the same as what's given to us. And that evaluates to 5525. Okay, so this is multiplied by 5,525. Okay. So if you work out your multiplication verticals, 4 times this number is essentially equal to 22,100. And that is the final answer. Let's look at this exercise problem. Express 3/16 as a power of 1 over 9. So here we have a 3 and a 9. 3 squared is equal to 9. So let's explore in that direction and see if we can convert 3/16 as a power of 1 over 9. So we have 3 squared is equal to 9. Now if we put raised to the power of 2, that means we have to multiply by 8 to match the original 16th power. So it becomes 3 to the power of 2 times 8. And we know from our exponent of exponent power rule, this is the same as 3 squared, this whole thing raised to the 8th power. Okay. So 3 squared is 9, so this becomes 9 raised to the 8th power. Okay. And we know from earlier, using the negative exponent, a 9 can be rewritten as 1 over 9 raised to the negative 1. So we're going to replace this 9 with this entire expression here. Okay, so bear with me that we're going to write this whole thing inside the parentheses, the 9, with this. That's 1 over 9 to the power of minus 1 right here. So again, using the exponent of exponent power rule, this becomes 1 over 9 raised to the power of minus 1 times 8. Okay, so this is equal to 1 over 9 raised to the negative 8th power. Okay, and this is our final answer. In this next exercise problem, it's asking which of these three numbers is the largest. So if you take a look at these, we certainly want to avoid hand compute all of these and then find out who is the largest. That's a lot of computation. Now when we compare exponents together, we either want to have them be in the same base and then do the comparison, or have them raised to the same power and then do the comparison. So right now, neither of them are the case. So let's take a look at the base here. We have 2, 3, and 5. So these three numbers does not seem to have a common relationship among each other. Now let's look at the exponent. We have 100, 75, and 50. So you can probably spot that 25 is a common factor to all three of these numbers. So let's look at in that direction. Let's try to convert these three exponents have raised to the same power and then see if we can make a comparison there. Okay. So we're going to rewrite 2 to the 100th as 2 to the 4 times 25. Okay. So using our exponent of exponent, the power rule, this is essentially 2 to the power of 4, the whole thing raised to the 25th power. Okay, so 2 to the 4th is 16, and that's 16 raised to the 25th power. Now let's look at our next number, 3 raised to the power of 75. So that's the same as 3 raised to the power of 3 times 25. Okay, so similarly, that's 3 to the 3rd, the whole thing raised to the 25th power. 3 to the 3rd is 27th raised to the 25th power. Now let's look at our third number, 5 raised to the power of 50. Okay, so that's 5 raised to the power of 2 times 25. Okay, so that essentially is 5 squared, this whole thing raised to the power of 25, which is 25 raised to the power of 25. Okay, so now you can see we converted these three numbers all to another set of numbers that have the same exponent, okay, which is 25. So when the number have the same exponent but different bases, the larger the base, the larger the number, okay? So therefore, in this case, we have the largest base, which is 27. So that means 3 raised to the 75th power is the largest number among the three. Let's look at this next exercise. Find the integer k such that 3 cubed plus 3 cubed plus 3 cubed is equal to 243 times 3 to the k's power. So there's a lot of 3's involved here. In order to find k, we must simplify these expressions and represent each number as an exponent with a base of 3 raised to some power. Okay? So let's start with our left-hand side and simplify the expression first. So this stands for left-hand side. Okay. We have 3 cubed added 3 times. So that's essentially 3 times 3 cubed. Okay. So we know that 3 is 3 to the power of 1 multiplied by 3 cubed. Okay. So from earlier, if we use the product rule, the multiplication of exponents with the same base, this is the same as 3 raised to the power of 1 plus 3. Okay, so this is 3 to the power of 4th. So that's what this left-hand side is equal to. Now let's look at our right-hand side. Okay, so this stands for right-hand side. So the number 243, okay, if you're to find the relationship of this number with the exponent, the base is 3, it actually comes down to 3 to the 5th power is 243. Okay, so that's 3 to the 5th power times 3 to the k. Okay, so using the same multiplication of exponents with the same base rule, we have 3 raised to the power of 5 plus k. So this is our right-hand side. Now, if we combine these two together, our left-hand side is equal to right-hand side. We have 3 to the 4th is equal to 3 to the 5 plus k. Okay. Now, in order to make these two the same, now we have the same base, we have to make the exponents the same. So that would make this k negative 1, so that 5 minus 1 is 4. So that will make these two numbers the same. So k is equal to minus 1. Okay, now let's take a look at this starting from here using a different method. Okay, so what we have is we have 3 to the 4th is equal to 3 to the 5 can be written as 4 plus 1 plus k. Okay. Now for visibility purpose, we're just going to group these two like that. Okay. So you can see that if we use the multiplication property on exponents with the same base, this is equal to 3 to the 4th multiplied by 3 to the 1 plus k. Okay. So now we have left-hand side is 3 to the 4th and right-hand side is 3 to the 4th multiplied by something. And to make these the same, this something has to be equal to 1. Okay? So that means 3 to the 1 plus k must equal to 1. Now we know that any number raised to the power of 0 is equal to 1. Okay? So these two gives us 1 plus k, the exponent has to be 0. So 1 plus k has to be 0. And this makes k minus 1. So we have the same answer. Let's look at our last exercise problem. Evaluate this expression. So here we have a number raised to the zeroth power. And we said that any number raised to the zeroth power is 1. So we have 1 plus 3 squared is 9 times 4 minus 2 times parentheses 14 minus 8 divided by 2 is 4. Okay. So what we have is 1 plus 36 minus 2 times 14 minus 4 is 10. Okay. So what we have is 1 plus 36 minus 20. Okay, that's 37 minus 20, which gives us 17 as the final answer. So this concludes our first lesson on exponents. Feel free to rework out any of the exercise problems, familiarize yourself with exponents and its properties, and we'll see you next time.